Okay, today we're going to talk about graphing functions. Last week we started into this, and we said that we could graph functions using the fact that the y-intercept is a point right on the y-axis, and then we use the slope to count to other points. But we have another option as well. Okay, another option that we can use to graph functions. Now first let's talk about what a function is. A function is a set of x values and y values in which every x is paired with exactly one y. Okay, it's a set of xy values in which every x is paired with exactly one y. Now, this can be represented with an equation. It can be represented with a chart. We can see the graph. We can even just have a set of points, just a list of xy coordinates. Okay, and all of those can represent a function as long as every single x is paired with exactly one y. Okay, now, a linear function. What word do you see inside of linear that might indicate what it means? Chase? Line. Okay, the word line indicates what linear means. Okay, a linear function is a function, so it's a set of x and y values in which every x is paired with exactly one y. And in this function, or whose graph, is a straight line. Now, what was the equation that we used last week that was a linear function? Very good. Y equals mx plus b. Okay, what was that called? Does anyone remember what that was called, Brielle? Bass? It is a formula, but it has a special name. This equation has a special name. It's called the slope-intercept form of a line. Okay, that's what it's called because m represents slope and b represents the y-intercept. So, slope-intercept. Now, last week, like we said, we talked about graphing it based on that function. Okay, we said that we can use the b, the y-intercept, to plot a point, and then we can use the slope, the rise over run, to count to two more points. Now, we have another option, okay, because not every equation is linear, and not every equation is in slope-intercept form. So we have to come up with some other plans. And this is a really good plan that can work all the time. In fact, when you learn about quadratic functions, and when you learn about exponential and logarithmic and absolute value functions and all this other stuff that you think I'm making up, but I promise you it's real, later on you're going to use XY charts to graph them. Okay, and that's what we're going to do today. We're going to make an XY chart with 3 points, with 3 x values. Now, I know you've made XY charts before. You may have called them input-output tables or function tables, but somewhere along the way, you made an XY chart. Okay? Now, we get to pick whatever x values we want, and we'll talk about which ones to pick a little bit later. But we pick whatever x values we want, and then we substitute the x values to find the matching or paired y values. Okay, every x gets exactly one y. So we take the equation, we substitute in an x value, and that function tells us what the matching y value is. So I know what x's and y's go together. I know that this x goes with that y, and this x goes with that y. Okay, now once I have those 3 points, I have x and y coordinates, we plot all 3 points. Take them onto that graph, and we plot those points. Now we take a step back at that point, and we make sure those points are in a straight line. If they aren't, we made a mistake. We go back and we fix it. Okay, but once they're in a nice straight line, Then we draw a straight line through all 3 points. Now, why through? We talked about this last week. Why did I put such an emphasis on that word through? Do you remember, Jordan? Very good. If your line stops at those points, you're telling me that the function stops at those points. I know that it doesn't. You need to show me that you know it doesn't. And the way you do that is you draw the line through all 3 points, and really, the best thing you can do is draw it all the way across the grid. Okay, so let's take a look at some examples, okay, where we do exactly this. Okay, we're going to make an XY chart. We're going to pick 3 X values. We'll sub each of those X values into the function, get the matching Y's, plot the points, straight line through all the points. Okay, so I have Y equals X minus 3. I'll start with my XY chart. Okay, and I get to pick whatever X values we want. Well, what do you think is the easiest number to work with? Definitely an integer. Absolutely. I'll stick with integers all day. But what else? What's the easiest number of all? 0. Okay? It's really, really easy to work with. No matter what I multiply it by, fraction, decimal, negative, it's always 0. And if I add it to anything, well, it's the additive identity. So that number stays the same. So I'm going to use 0 almost every single time. There are very, very few instances in which I won't use 0. Okay, and don't even worry about those because those are down the line. Now, Nick said integers. He said even numbers. I like even numbers. I like integers. I think they're really good numbers to use. So let's pick small integers close to 0. Now, here's the thing, though. For our graphs, what's really beneficial for us is to pick one positive and one negative. So maybe 2 and negative 2. Okay, small numbers, easy to work with, close to 0, integers, one positive, one negative. Now, 1 and negative 1 are good too, but they're a little too close to 0. So when I plot those points, I end up having my points a little too close. So I like to use 2 and negative 2, or maybe 3 and negative 3 if I can. Okay? That allows me to have the points close to 0, but not so close that my graph looks messy. Okay? So now I've made my XY chart with all 3 X values. I'm going to substitute each of those values into the function. Okay? So I have 0. I'm going to put 0 right here in place of X. So I'll say Y equals 0 minus 3. Well, 0 minus 3 is negative 3. So that means that when my X value is 0, my Y value is negative 3. Okay, then I'll do the same thing for the other two. So Y equals 2 minus 3. And 2 minus 3 is negative 1. So when my X is 2, my Y is negative 1. Okay, then lastly, I'll use negative 2. Okay, we'll say Y equals negative 2 minus 3. Well, negative 2 minus 3 is negative 5. So that means that when my X is 2, or excuse me, when my X is negative 2, my Y is negative 5. Okay? Now, I have my XY chart with all 3 points. I want to take those 3 points and I want to put them on the graph. Now, like I said, guys, we're going to have to fit 2 graphs on the front, 3 on the back. So space them accordingly. Okay, and let's plot 0, negative 3. So 0, negative 3 means no steps left and right, 3 steps down. 2, negative 1 means 2 to the right and 1 down. And then negative 2, negative 5 means 2 steps to the left and 5 steps down. Okay, then we take a step back and look. Do those points make a straight line? Looks pretty good to me. So I'll draw the straightest line I can through all 3 of those points. And in fact, I'll draw it all the way across the grid. Okay? Gabriel, I saw your hand. Hold on to your question. I promise I'll answer it. Okay? Okay, next up. I have y equals negative 3x. So, xy chart. And I get to pick any x values I want. Any x's at all. Well, what's a great place to start? Primes are okay, sure. 0. 0 is a great one to use every single time. Now, Bass said prime numbers, as long as you're using small ones, that'll be okay. Okay. Now, we get to pick whatever x values I want. So 2 other ones. I like 2 and negative 2. Okay. They're small numbers. They're easy to work with. Multiplying by 2 is something we understand. They're close enough to 0 that I don't have to worry about my graph getting too big, but they're far enough away that I don't have to worry about my graph being too clustered. They're good numbers to use. So now I want to take each of these x values and substitute them in place of x right here. So I'll do y equals negative 3 times 0. Well, negative 3 times 0 is 0. So that means that when my x is 0, my y is 0. Then I'll do the same thing with 2. So y equals negative 3 times 2. Well, negative 3 times 2 is negative 6. So when my x is 2, my y is negative 6. Okay, then I'll do the same thing with negative 2. Y equals negative 3 times negative 2. Y equals 6. So when my x is negative 2, my y is a positive 6. So now I've got those 3 points. I want to take them and plot them on the graph. Well, 0, 0. Jess, where does 0, 0 go? Right smack dab in the middle. Not left, not right, not up, not down. Just right there in the middle. Okay, Gracie, what about 2, negative 6? Oh, I thought you were going the way you're pointing. 2 to the right, because it's positive. Very good. 2 to the right, and then down 3, 4, 5, 6. Okay? Jordan Boyd, what about negative 2, 6? Which direction? Left 2, and up 6. 3, 4, 5, 6, and there we go. Now take a step back and look. Are your points in a nice straight line? Looks pretty good. Okay, so we'll draw the straightest line we can through those points. And there we go. There's our graph. All right, Priya, what was your question? Okay, why do we pick a positive and negative? Really just to keep the graph balanced. There's no rule that says you have to use a positive and a negative. When you make your XY chart, you get to pick whatever ones you want. I like to pick one on the left and one on the right and 0 in the middle. To me, it just makes the graph seem a little more balanced, and we get to see both the positive and the negative side of the graph. Okay? Nick, sign out with the hall pass. Okay? You absolutely can use fractions. I like to avoid using fractions as much as possible. Okay, if I have to, that's fine. But if we don't have to, I'm not going to. And the reason for that is when we have to graph them, then we have to kind of estimate where a half is or where a third is. Halves are okay, but anything other than a half can be really, really difficult to graph. Okay, because then we really have to estimate where like thirds and quarters and all that business are. Ones are okay. They're really simple numbers to work. They're easy to work with. But the problem is, if I use ones for my x's, I'm going to end up with those points, and they're really, really close together with that 0. If I don't have these ones out here, that can be a little bit be a little bit tough to graph. Okay? If all I have is that, okay, graphing those points super close together, I can get a little messy. It can get a little sloppy. Okay, so instead, we use the 2's. Okay, they're close enough to 0 that they're still easy to work with, but they're far enough from 0 that we can get a good picture of the graph. You can use any real number that you want. Okay, you can use pi if you want to. Okay, the only problem is if you're using anything other than an integer, it can be very difficult to graph because then you're estimating where that fraction is on the grid. Okay? Yeah. No, I didn't. No, we didn't. We ended up with fractions as our slope, but we didn't. We tried really, really hard not to plot any fractions. In fact, I don't think there were any that we did. Okay, we ended up with fractions when we were finding the slope. Yeah, and we're going to see that today. But we're going to try not to have fractions that we have to graph if we can avoid it. You're thinking about the slope. You're talking about the slope. Okay, and we did. When we counted rise over run, we absolutely did. But I'm talking about points on the XY chart. And there's a big difference between that slope, rise over run, and the XY points. Okay? All right, let's take a look at a couple more. Okay, let's take a look at number 3, on my back anyway. Okay, and we have y equals 5 minus 2x. All right, now, we're going to begin the same place we always do. We make an XY chart. And we get to pick whatever x values we want. Okay, well, let's stick with the ones that have been working for us. 0, 2, and negative 2. And let's take each one of them and substitute them in. So y equals 5 minus 2 times 0. Okay, I'm putting 0 in place of x. Okay, Chase, what's 2 times 0? And what's 5 minus 0? Y equals 5. So when my x is 0, my y is 5. Okay, let's do the same thing with 2. Maddie, what would that look like if I substituted 2 in place of x? A little bit more. Not quite. All I want to do is take this equation right here, and I want to have it exactly the same, except instead of x, I want to put 2. Okay, so I got 5 minus 2, but what about the x? Not minus 2, times 2. Okay, y equals 5 minus 2 times 2. Okay, all we're doing is putting those numbers in place of that x. Okay, we're substituting. So Maddie, what's 2 times 2? And what's 5 minus 4? Good. So when my x is 2, my y is 1. Okay? Then we'll do the exact same thing for negative 2. Okay? Scott, can you substitute negative 2 for us, please?
Y equals 5 minus 2 times 2.
Very good. Okay? And Bergie, what's 2 times negative 2? Negative 4. And what happens when I have minus a negative? Courtney, what happens with minus a negative? Very good. It becomes plus plus. Okay, and 5 plus 4 is 9. So that means that when x is negative 2, y is 9. Now, I'm going to do something here, guys. I don't want you to copy it down. I just want you to watch for a minute. Okay? I have a couple of options. Okay, 9's a pretty big number, so I have a couple of options about how I can graph it. One, I can make the graph bigger. Okay, but if you have a limited amount of space on the paper, that's not always an option. Option number 2 is we can use a scale. Okay, we can say, like I said, I don't want you to copy this down. We can say that each one of these grid lines is 2. So here's 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Negative 2, negative 4, negative 6, negative 8, negative 10. Negative 2, negative 4, negative 6, negative 8, negative 10. Okay, but what's the problem with that? There's a couple problems. What's one of them? Okay, now if I have an odd number, I'm estimating again. I'm back to dealing with fractions. Okay, my graph's going to be clustered, everything's smashed together, and there's also going to be a whole lot more writing than I need to do. Okay, so let's not do that if we can avoid it. Now, there are times when that's the best option. Okay, there are times when that's the best option, and you'll know when those times are when the time comes. Okay, but our option number 3 is we add another point. Okay, we recognize that as we go to the right, our y values get smaller, and as we go to the left, our y values get bigger. Well, at negative 2, it's already too big. So let's pick a point on the right. Let's use 4. Okay, so we'll do y equals 5 minus 2 times 4. Well, 2 times 4 is 8, and 5 minus 8 is negative 3. So if my x is 4, my y is negative 3. Now, there's nothing wrong with the point negative 2, 9. It's 100% correct. It's just a little bit too big for our graph. Okay, so we'll pick a different number, pick a different x, substitute it in, get a different y that'll fit. So 0, 5. Jess, where's 0, 5 going to go? Just up 5. Not left or right, just 1, 2, 3, 4, 5 steps up. Okay, Crystal, what about 2, 1? To the right 2, and then up 1. And Katia, what about 4, negative 3? Very good. 4 to the right, and 3 down. Okay, but take a step back and look. Does that make a nice straight line? Sure does. So draw the straightest line we can through all 3 points, across the grid entirely if we can. Okay, and there we go. All right, questions about 1, 2, or 3? If you have questions, guys, now's a good time. Yeah.
So anytime you think that a number's too big, we can just use a different number?
Absolutely. If the number's too big for your graph, you can use a different number. Now, there will be times, depending on, and the bigger n and b are, you're going to end up with times where you just have to use big numbers and there's no way around it. Okay? But if you can't avoid it, we like to. Okay, just to make our graph a little more compact, a little less wasted space on the paper. Okay. All right, I'm going to have you guys talk me through number 4. Okay, what's the first thing I'm going to write down on number 4? Hannah? An XY chart. Now we get to pick whatever x values we want. So what will be a good x value to pick? Where's a good place to start? Dugan? 0. 0 is always good. Okay? What else would work here pretty well? Quentin? 2. And if you're going to use 2, what should you use along with it? Negative 2. Okay? So we've got an XY chart with 3 x values. Nolan, what now? Okay, so what would that look like? Okay, keep going with this. So when my x is 0, my y is 1. Okay? Then what? What next, Nick? Okay, so do the same thing with 2. Great. Okay. And then, I haven't heard much from Crystal. What now? Great. Great. Keep going. -3. Y equals -3. So when x is 2, my y is 5. And when x is -2, my y is -3. Okay, now let's take those points and let's put them on the graph. Okay, so 0, 1. Barsha, where does 0, 1 go? Okay, and Gracie, where does 2, 5 go? Very good. And then Sage, what about -2, -3? Very good. Okay, take a step back and look. Do those points make a nice straight line? Looks pretty good to me. Okay, so we'll draw the straightest line we can through all 3 points. Okay? Okay, we're just about out of time, so we'll talk about what to do when we have fractions tomorrow. But please don't pack up. Please just listen. Okay, when we want to graph, okay, we have 2 options. The option that we talked about last week was using the slope-intercept form. Plot the y-intercept, use the slope to count to other points. Option number 2, what we did today, is making an xy chart using a function table. So we make an xy table, pick 3 values for x. What's a really good number to always pick for x? 0. Okay? And then small integers close to 0. 1 positive, 1 negative. Substitute them in place of x, find the matching y's, plot your points, draw a straight line through the points. Okay? Now, guys, like I said, we'll talk about what to do with fractions tomorrow. There's really not a whole lot different, okay, just a couple of tricks we can use. And we'll have some homework on graphing tomorrow. But for tonight, your only homework is to study your notes. Okay?